For this exercise, I downloaded Caterpillar's complete financial statement from Compustat between fiscal year of 2000 and fiscal year of 2011. When you first opened up this downloaded Excel file, I want you to immediately rename the Data tab to Raw so that you and your colleagues know not to touch this tab when doing your analysis. Let's take a look at what's included in this Data tab. The first statement is Statement of Financial Position. It has information such as assets, liabilities, and shareholders' equity. So it's a balance sheet for Caterpillar. The second one is income statement. It has sales, SG&A, all the way down to net income. And third statement is retained earnings. For creating a DCF model, we don't really need this information. The fourth one is statement of cash flows. Cash flow is not paramount important to us, but it's a statement that's good to have because it will come in handy when we want to quickly replicate the past free cash flow numbers. So we'll still retain this information. The other information is extra. We don't need them for this exercise. So the next task is to quickly extract the relevant information and copy them over to their respective tabs. Specifically, I want you to copy over the information for balance sheet, income statement, and cash flow statement. Once you copy over the information, you know where to quickly find them when you need particular information from these statements. After this is done, your database is ready and we can start to do some preliminary analysis. Most of the DCF models are sales-driven. That means all the forecast line items on your DCF models are pegged to sales. Therefore, it's very important that you do a good job estimating the sales growth rate going forward for forecasting purposes. In this exercise, I want to show you different ways to estimate sales growth rate, but there is only one best way to do it. Sales is the top line item in the income statement, and therefore you will go back to your income statement in order to find the sales information. You will select the sales information for each fiscal year, and you will also select all the fiscal years. Copy and then go back to the sales analysis tab. And there you'll find an empty spot, and then you will bring out the paste special window to paste all the information into columns by checking this transpose box. And next, you will do a little editing to make sure your numbers look good. What this sales number means here is for fiscal year of 2000, the sales number is $20.175 billion. The next step is to convert all the sales information into percentage growth rate. Because the time interval here is on a yearly basis, and therefore we shouldn't use log returns to compute what is the percentage growth rate. We should use percentage return instead. So to compute percentage returns, you will use this year's sales divided by the previous year's sale and -1. And then you can use fill handle to complete the rest of the column for you. Once you complete the annual growth rate based on the annual sales number, then you can compute what is the average growth rate based on average sales growth rate from this period. So this is the first measure to estimate average growth rate for this period. So you will just apply average on the annual growth rate, and that gives you annual growth rate for sales that equals to 12.58%. But the problem for calculating the historical averages and apply this growth rate to future sales growth rate is that this measure is largely driven by outliers. So this measure might not be accurate when you apply it to the future growth rate. The second measure is to use CAGR. CAGR is the annualized buy and hold return. that take into consideration all the compounding effect. So if you use CAGR to compute the estimated sales growth rate, then you will use what is the sales at the end of the period divided by the sales at the beginning of the period, and then calculate what is the root by using to the power of 1 divided by n. N in this case equals to 11 because from 2000 to 2011 there are only 11 years, and then minus 1. And this way you compute what is CAGR for this 12-year period. Here's the one problem for using CAGR as the future sales growth rate. That is, depending on what is the beginning point and ending point for estimating CAGR, your CAGR estimated CAGR is very different. For instance, if you start computing CAGR based on 2001 to 2011, then the CAGR is 11.39%. But if you compute CAGR using a different time horizon, for example, from 2001 to 2010, you see your CAGR is only 8.49%. So CAGR is very affected by the starting point and ending point of your analysis. The third measure for estimating the future sales growth rate is using the estimated regression slope. So if we run a one variable regression where the dependent variable is the annual sales number and then the independent variable is the fiscal year, so this will be the y variable and the year will be the x variable. You regress y on x. The slope gives you what is the average change in sales on the year-to-year basis. You can estimate the slope of this regression using two ways. The first way is simply enter a slope formula. The first argument is also y variable. In this case, it will be sales. And the second argument is also x variable. In this case, will be all the years. And then enter. The estimate from using the slope function give you 3,205, and that means on average, the change in sales for Caterpillar is $3.2 billion on a year-to-year basis for Caterpillar. And once we figure out what is the average change in sales on a year-to-year basis, then you can use this number divided by the most recent sales number to compute what is the average sales growth rate. So you will use this number divided by the most recent sales number, and you can replicate 5.33%. There's another quick way to estimate the slope from this one variable regression is by fitting a trend line on the scatter plot. Okay, let me show you how to do this. So if you select the first two columns for sales, including the fiscal years and the sales, and then you can go to the Insert tab in the ribbon and then do a quick scatter plot to plot all the annual sales number from 2000 all the way until 2011. And once you do the scatter plot for the sales number, then you will click on the sales number and then right click and click on Add Trend Line in order to fit the underlying data with the best fitted line. And in this case, because the data is more or less linearly distributed, so you will use the linear trend line function. You will click on linear, and then not done yet, you will scroll all the way down, and then you will click on these two boxes here, display equations on chart and display R-squared values on chart. And this way, Excel estimated what is the equation for this trend line for you. So based on this estimate, you see Y is the annual sales number and X is the fiscal year number. The slope is equal to 3,205, which matches with this slope estimated by the slope function. And this number right here is the intercept. You can also similarly estimate the intercept of this regression using the intercept function. And the R-square measures what percentage of Y variable is what percentage of the Y variable can be explained using the x variable. And in this case, R squared is equal to 76.13%. So that means the x variable, in which case is year, can be used to explain 76.13% of variation in sales. Okay, so once we know how to estimate the slope from this one variable regression, then we can compute more robust measure for the sales growth rate on a year-to-year basis. And the result is 5.33%. And then comparing to other two measures, we believe this measure is more robust, and we can apply this sales growth measure to forecast the sales in the future. Last but not least, I also want you to complete this plot by just doing a little formatting to make sure that the trend line is showing disconnected. The trend line, the scatter plot is collected using dotted line, and the trend line is displayed in a solid line, as you see in the matching plot on the right.